afternoon, everyone. Today we'll start topic 1.7, which is about the energy, work, and power. First, the learning objective. These are the learning objective of this topic that you should understand the concept of energy and different forms of energies as well as conservation of energy. So first, the concept of energy, how we define energy. Energy simply means ability to do work. Example, if an object is placed on the horizontal surface and I'm applying force on the object, so that this object can move from one place to another. So I apply the force on the object and the object moves from position A to position B. So when we are applying force in the we can move the object. So what we do, we or what we say we did a work done or a work is done. So ability to do work. If anything is able to do work, if anything is able to exert force and move the object to certain distance, we say that thing is having energy. So simple definition of energy, it is ability to do work. So example, if there is an object and I'm applying force, like example, this is a wall and I'm applying force on the wall. And the wall does not move. So if I'm applying force on the wall and the wall does not move, is there any work done? There is no work done because I'm applying force, but I'm not able to move this object. So here the work done is zero. So it means I have energy, but I don't have sufficient energy to do the work. So sometimes we have energy, but we don't have sufficient energy to do the work. So in this case, the work done is zero. So simple definition of simple definition of energy is ability to do work. So if we are able to do work, means we have energy, sufficient energy. If we are not able to do work, we don't have sufficient energy. So everything in the world is able to do work because of energy, and energy is basically a capacity of doing work, or we can say the ability of doing work. And what is the main source of energy? Different energies are there, but what is the main source? The main source of energy is the sun. Like most of the energy, when we discuss the types of energy, the most of the energy started with the sun. So sun is refers to a main source of energy. And the unit of energy, what is the unit of energy? Unit of energy is joule, or you can also write kilojoule. And what is the relation between joule and kilojoule? That 1 kilojoule is equals to 1000 joules. Is it clear the concept of energy? Energy is simply the ability to do work. If you are able to do work, it means you have energy. Then there are different forms of energies. So energy have different forms. It can be a chemical energy, kinetic energy, potential energy, light energy, sound energy, thermal energy, solar energy or internal energy or heat energy, electrical energy, nuclear energy, wind energy, and strain energy or elastic strain energy. So these are different forms of energies. You just have to know the basic idea of each form of energy. You don't have to learn the formulas except two of them, which you will learn the formula. You will learn the formula for kinetic and potential. So now we'll discuss each form of energy. First thing, chemical energy. So what is the chemical energy? Energy which is a stored energy and it can be released by a chemical reaction. So example, the food or the fuel, they all have chemical energy. Like batteries also having cells, batteries, they all have chemical energy. So what is the concept of the chemical energy? The energy which can be released by a chemical reaction. Like example, you have 1 kilogram coal. So you have 1 kg coal. If you want to release energy, like example, if you want to cook food or if you want to make barbecue or you want to produce heat, what you do, how you release the energy from the coal. So what we do, how we release energy from the coal, we burn. So when we burn the coal, it releases energy. But basically what is burning? When we burn the fuel, burn the coal, it releases energy. What is burning? Burning is a chemical reaction. So when we release energy from anything by a chemical reaction, what we call that energy as the chemical. We say that the object was having a chemical energy. Same way, the batteries, the cells which you are using in remote control. So what happens inside the cell when you connect a bulb or a lamp? The lamp light up. But how the lamp light up? What is happening inside the cell? Inside the cell, there is a chemical present and there is a chemical reaction inside the cell. So whenever a chemical reaction produces energy, what we call that energy? We call that energy as a chemical energy. So whenever you have food, fuel, batteries, they all have chemical energy. Is it clear the concept of chemical energy? So as you can see here, the coal, the batteries, cells, they all have chemical energy. Even the food which we eat, that is also having a chemical energy. Why? Because the food which we eat, so inside our stomach, there is a chemical reaction take place with the food and then it releases the energy. So whenever a chemical reaction produces energy, we call that energy as a chemical energy. The second kind of energy, that's called kinetic energy. What is the meaning of kinetic? The term kinetic refers to moving. Anything which is moving is known as kinetic. So the energy which moving objects having, like anything which is moving, any kind of motion, like here you can see a sports car is moving on the track, so it will have a kinetic energy. A bus moving on the track or the road, that's also having a kinetic energy. So objects which are moving faster, they have greater kinetic energy. And objects, if two objects having the same mass, the one which is moving faster will have a greater kinetic energy, and the one which is moving slower will have smaller kinetic energy. So anything which is moving will have kinetic energy. Example, if you are walking on the track, the definition of kinetic energy, the energy which moving objects having, that is known as kinetic energy. So energy, how it can be produced? It can be produced by different ways. Like example in our body, what we do, we eat food. So when we eat food, what we have chemical energy in our body. But as you use your legs, move your legs, and you move from one place to another, so basically the chemical energy of the food is used as a kinetic energy. Same way inside the car. So what we have inside the car, we are using a fuel. So there is a fuel present inside the car, and fuel will have a chemical energy. So when the car engine burns the fuel, that chemical energy changes into kinetic energy. So it can be produced by different ways, but whenever the object is moving, moving objects always have kinetic energy. Is it clear, the concept of kinetic energy to everyone? An object can have two forms of energies at the same time. Like example, if this car is having a fuel, so it is having a chemical energy, and this car is moving as well, so it is also having a kinetic energy. So two forms of energies, car may have two or more forms of energy at the same time. Then the third form of energy is called potential energy. The energy which is stored in the object due to the change in the height, or when object is raised to certain height, it will store some energy, and we call that energy as potential energy. So example, you have a box which is on the floor. So this box is there on the floor, and you lift this box from the floor to the shelf. So whenever you lift an object, you raise the object to certain height, the object will store some of the energy. Whenever object lifted to certain height, it will store energy. And which form of energy this object will have? It will have potential energy. So the object stored energy due to the change in the height, we refers to potential energy. And greater the height, greater the potential energy. So if you have two cases, you're lifting the object to different shelves. One is the lower shelf, another one you're lifting to a higher shelf. Both cases the object will store energy as a potential energy, but which one, A or B, object will have greater potential energy? Like student A lifted the block to shelf A, student B lifted the block to shelf B. Which case the block will have greater potential energy, A or B? The potential energy is the energy stored due to height. Yeah, what about others? Abdullah Khan, Saim, Shazib, Hiba. So that's right, B, because it is raised to a greater height, the height which is raised or moved from the ground is higher, that's why it will store greater potential energy. So whenever objects are at certain height, force and energy is a different thing. Energy, when you are applying a force and you move the object to certain distance, the object will store something, and that we called as energy. So ability to do work is known as energy. So here, as you can see, this is a waterfall. So which form of energy the water particles are having at the height? Which form of energy when they are at certain height above the ground? So as they are at certain height above the ground, so they will have potential energy. But as this water is coming down, because this water is falling, So this water is moving as well. At this point, because the water is moving, so it will have kinetic as well as it is already at certain height, so it will have potential. So it will have both kinetic and potential at this point, because the water is at certain height above the ground and water is moving as well. But when if it was not moving, like example, if we consider the water particle at this point, which example not moving, so it will have only potential. When it is coming down to position B, it will have potential and kinetic. But when it is on the ground only moving, so it will have kinetic only. Is it clear? The concept of potential energy. Same thing, example, a coconut is falling from the tree. So when this coconut was there attached, which form of energy it will have? When it is attached and it is above the ground, that is only potential. That's good, Abdullah. But when it is coming down and still it's above the ground, so it will have potential as well as kinetic. But when it just hit the ground, it will transform to other forms. Light energy, what is the concept of light energy? Anything which glow, anything which emits light, we call that is having a light energy. Example, sun is producing, or it's producing light, because we are receiving light also and we are receiving heat also. So anything which glow, emit out light, that will have light energy. Same thing, sun is also producing heat, so it is also having heat energy. So when objects glow, emit out light, we call they have light energy. Thermal energy, or we can also say heat energy. The energy which is coming from the objects or hot objects, we call that as a heat energy or thermal energy. Like example, the sun is producing light also, and it is also producing heat. But this thermal energy or heat energy is basically divided into two categories. Heat energy can be thermal energy, it can be internal energy. What is the concept of internal energy? Internal energy means the total energy of the particles. So the total energy of the particle is known as internal energy. Like you have an object which consists of particles, say 5 particles are there, and they have different energies. This is having 2 joules, 3 joules, 4 joules, this is 2 joules, and again 3 joules. So what is the meaning of internal energy? It is the total energy of the particle. When we add the total energy of the particles for the material, like first particle is having 2 joule, the second particle is having 3 joule, third particle is having 4 joule, fourth particle is again 2 joule, and fifth particle is having 3 joule. So when we add this 2 plus 3, 5, 5 plus 4, 9, plus 2 11, and 11 plus 3 14. So that 14 joules, the total energy of the particles, that sum of energy of the particle, what we call that as internal energy, or we can also say heat energy, because you can use the term internal or heat. But what is the meaning of thermal energy? The thermal energy means the change in the internal energy. So when the internal energy changes for the object, we call that as thermal energy. Example, three particles here for the same object, but initially the particle will having energy like 5 joule, 6 joule and 5 joule, and then it changes to 3 joules, 4 joules and 3 joules. So what is the internal energy before? At the start, what is the total internal energy? 5 joule, 6 joule and 5 joule. So 5 plus 5 10 plus 6 16 joule. So the total energy is 16 joule. What is the internal energy afterwards, after some time? 3 plus 4 plus 3, so that's make 10 joule. So what is the change in the internal energy? How much internal energy changes? That is 6. So the change in internal energy, the change in the internal energy is called thermal energy. So how much change in internal energy occur? 6 joules. So we say the thermal energy is 6 joules. Is it clear, the concept of thermal energy and internal energy? So when the object internal energy decreases, it will release the energy, and if internal energy increase, it will absorb the energy. So internal energy is the stored one, and thermal energy is what is transferred to the surrounding or from the surrounding. For example, we are burning a trash example. So when we are burning a trash, which form of energy it will have? It will have thermal energy, or you can also say heat energy. Sound energy, what is the concept of sound energy? When anything vibrate, it always produce sound. But like example, all the sounds are not audible, because there's a frequency range, there's an audible range for our ear. All the sounds we cannot hear. There's an audible range. We can hear the sound which is producing 20 vibrations per second to 20,000 vibrations per second. This is the audible range for a normal human ear. For animals it vary, but for humans, the normal, because even for human ears, they have different audible range. It changes with the age, but for normal human ear, the audible range is from 20 vibration per second to 20,000 vibration per second. So any vibration within this range, our ear can detect. If it is less than 20,000, less than 20, we cannot hear. If it is more than 20,000, we cannot hear that vibration, or we cannot hear that or record that sound. So example, if you take a pencil or a pen and you're vibrating this pen or pencil, can you hear the sound produced by this? If you have right now with you the pen or pencil, can you hear the sound? You're not able to hear the sound from that. Why you're not able to hear the sound? Because that vibration, it is vibrating, it is producing sound, but that is not in the audible range, because the audible range is from 20 vibrations to 20,000 vibrations. That is what we can detect. So anything which is vibrating produce sound, but all the sounds are not detectable because of our limitations. So if you have, like example, a loudspeaker cone, what happen? You can observe this motion when you play a music or you play any kind of sound. So what happened to the cone? This cone start to vibrate. So when this cone is vibrating, what it cause? It cause the air particles, because air particles are around the cone, and it is also causing the air particles to vibrate. And if it is producing a sound, normally it is in an audible range, so our ear can detect that sound. Is it clear, the concept of sound energy? Any question or a doubt? Saim, Heather, Bashara, any question or a doubt? So whenever anything is vibrating, it will always produce sound energy. Electrical energy. What is the electrical energy? Energy due to the moving charges. When the charges, the particles, and normally what are the charges moving in the wires? In the wire we have electrons. So energy due to the moving charges, that energy is called electrical energy. Example, say this is a bulb, a lamp, this is the symbol for the lamp, and you connect a battery, which is having positive and negative terminal. Then you connect the wires. The moment you connect the wire, what you observe? You observe that the lamp light up, or lamp start to glow. Now basically what happened, inside a cell or a battery there is a chemical reaction. So which form of energy there inside the cell? It will have chemical energy, because there is a chemical energy as the chemical reaction take place inside the cell. Because of this chemical reaction, what it produce? It produce electrons. Due to a chemical reaction, electrons are produced. And what happened to these electrons? These electrons start to move. So when these electrons start to flow in the wire, which form of energy these electrons carry? They carry electrical energy. And when these electrons move through the lamp, passes through the lamp, they transfer their energy. When these electrons transfer their energy, which form of energy lamp produce? The lamp will produce a light energy. So basically it's energy transformed from one to form to another. So whenever energy is there due to the moving charges, moving particle, what we call that energy? We call that as electrical energy. So inside the wires where the electrons are moving, flowing, we call they have electrical energy. Is it clear? The concept of electrical energy? So basically energy changes from one form to another. First it was chemical, inside the battery there was chemical, a chemical reaction produce electron. So when these electrons start to move, they have electrical, and when they start to flow and transfer energy to the lamp light up, so it will convert into light energy. So energy transformed from one to another, where electrical energy refers to energy in the moving particles. And when electrical energy is there, it also produces heat and light. The nuclear energy. The nuclear energy, the energy released from the nucleus of the atom, we call that as nuclear energy. As we already discussed in chemistry, the structure of an atom consists of nucleus. Inside the nucleus, we have neutron and proton, and around the nucleus, electrons are moving. In the definite region, what we call that region, we call that as shell. So this is the nucleus. This one is called orbit, and around the nucleus, electrons are there. Inside the nucleus, neutron and proton. So the energy released from nucleus of the atom, the energy which is released only from this part, we call that as a nuclear energy. But how nuclear energy can be released? It, it can be released by two ways. Or it can be released by nuclear reactions, and there are two nuclear reactions. One is called fusion, and another one is known as fission. So there are two ways by which we can release the nuclear energy. One is called fusion, another one is fission. What is the meaning of fusion? Fusion means when we join the lighter nuclei, so when the lighter nuclei join, the nucleus release energy, we call that as nuclear fusion. And when the heavy nucleus break down, it is opposite. So when the heavy nucleus break down and release energy, we call that as nuclear fission. Like example, you have two nuclei having one proton, one electron, and another one also having one proton, one neutron, and one electron. So when you combine them together, when you join them together, when you fuse them together, so when these two nucleus or atom join with each other, their nucleus will actually join. And what will be the resultant nucleus when they join with each other? It will be two proton, two neutron, and two electrons. So as you can see, the smaller nuclei, the lighter nuclei join together and they form a heavy nucleus, and it will release energy. So which form of energy they release, or which form of energy they have a nuclear energy. And opposite will happen if we have a heavy nucleus. Heavy nucleus means having many particles. Electrons are also there, but I'm not drawing an electron because our main focus is the nucleus. So when we have lot of particles inside the nucleus and we break down this nucleus or we hit this nucleus by neutron, so that it will break into lighter nuclei, smaller nuclei. So when the heavy break down into lighter, this type of nuclear reaction is known as nuclear fission reaction. But when the lighter nuclei join to form a heavy, this type of nuclear reaction is known as nuclear fusion reaction. And nuclear fusion reaction, it happen on sun or stars, and nuclear fission reaction we do on different nuclear power stations. How we break the nucleus? We target the nucleus by the neutron. So when we target the nucleus by the neutron, this neutron break down the nucleus into two parts, and a heavy nucleus split into two parts and release energy. So this energy is released by a nuclear fission reaction. Is it clear, the concept of two nuclear reactions, fission and fusion? Yeah, they are very small, that's right. But how we target? So we take millions or trillions. Like we have an atom, and we target this by millions or trillions of neutron, and one of them is able to split them or break them into a lighter one. So a nuclear energy, the energy which is stored in the nucleus, is called a nuclear energy, which can be released by two ways: nuclear fission and fusion. So these nuclear bombs or hydrogen bombs, they also use a nuclear reaction. On the sun as well, at the surface of the sun, there is a nuclear reaction. I'll share another link and continue this discussion of nuclear energy.